So today we're going to start the last unit, which is on finance. Um, in this first section, we will be looking at simple and compound interest, which is you're probably very familiar with simple interest, and then you may or may not know too much about compound interest, but we'll talk about how to compute both of those. We'll first start with simple interest. You can see from the formula I equals PRT. That's your formula for simple interest. I stands for your interest. P is your principal, the amount that you put into an account or the amount that you borrow. R is your annual percentage rate. It should be a decimal. So again, like we talked about before, if you need to make it a decimal, you take that percent and divide it by 100 or move your decimal 2 places to the left. Time is always measured in years. And your accumulated balance would be, at the end of the loan term, how much do you have to pay back? How much you borrowed plus interest, or at the end of a term, if you've been investing your money, how much do you have in the end? How much you put in plus the amount of interest that you earned. So that's 2 ways to think about that. It should be noted that here the simple interest is in terms of borrowing or investing your money. Go back for a moment. Let's look at this time being measured in years. Um, it's really important that your rate is always in years for these for most problems. If it doesn't specify, it's always in years. If your rate was in a different form, it would say a monthly interest rate or a daily interest rate or something like that. But if it just says, oh, here's your interest rate of 5%, then they're saying, okay, that's an annual rate. So that means my time needs to be in years. So for that reason, sometimes your time might be given to you in months. So in order to convert months to years, because those months will be part of a year, you just put that over 12, i.e. take that number of months and divide by 12. Likewise, if you were given a certain number of days, and that's a fraction of a year, you want to figure out, well, what fraction of the year that is, you just take that number of days and divide it by 365. I just put a note in here, most banks do use 360 rather than 365, but since your book used 365, I went ahead and went with that. And the difference between the two is very negligible, so it's not going to make that big of a difference in terms of, the amount of money that you're talking about. So let's look at example 1 together. It says that Kim needs to borrow $1,600 to have corrective eye surgery. From her bank, she obtains a 2-year loan at an interest rate of 6.5%. So this is what I meant by it's just a plain old 6.5%. It's not saying it's a monthly interest rate or anything like that. So we assume that 6.5% is a yearly rate. My time needs to be in years. It is, so we're good to go. It says 2 years. So part A says calculate the simple interest. So simple interest, your formula, I equals PRT. In place of my P, how much I'm borrowing, 1,600. Interest rate 6.5%, so change that to a decimal, 0.065, times my time, times in years, so multiply it times 2. Pop that in the calculator, and I should have $208. So that would be the amount of money that she's going to have to pay for having gotten this money up front. So in part B, it says, well, how much then is, in the end, at the end of this 2 years, how much is Kim going to end up having to have paid the bank back? She's probably going to make, payments along the way, but in the end, her payback amount is principal plus the interest. So she's going to have to pay back, of course, the $1,600 that she borrowed plus the interest that accrued, $208. Add those two together for a final answer of $1,808. Okay. In example 2, I'm just going to briefly talk about the difference between A and C and let you fill in B and D. Here, Stephanie wants to borrow $5,600 to add a pool to her house. Her parents offer to help her out with a 14-month loan at a simple interest rate of 4.5%. They agree that she has to pay them back in full at the end of that time frame. So in part A, it says, well, how much does Stephanie have to pay in interest for this loan? So interest, I equals P. How much is she borrowing? $5,600. Your rate, 0.045. And your time, and this is where I want to really hit home here, you're seeing here that the time is a 14 months. So I need to convert those 14 months into years, so I put 14 divided by 12. And you can type that into your calculator from left to right. and your calculator should give you the answer. I would prefer you not to do the 14 divided by 12. This one might come out, yeah. If you do 14 divided by 12 in your calculator, just for example, you're going to get 1.166667. And what I see folks often do is they'll take that number and then they'll round it. And by rounding this and then multiplying it times this and this, you're going to end up rounding twice. The best way to do this is just to multiply 5600 times 0.045 times 14 divided by 12. You type it all in like that, and then not do any rounding until the very end. And after you've done that, you probably find that you don't have to do any rounding at all. It comes out to an even nice whole number, $294. Okay. I'll let you do B. It's very similar to what we just did in the previous example. C, though. C, Stephanie gets a little lazy. She says, well, I think I want a little bit more time to pay off this loan, maybe taking advantage of her parents. How much would it cost her then if she finances the money for 3 years as opposed to those 14 months? So figure out, okay, what's her new interest amount? She's still going to borrow the same amount at the same rate. But now your time is in years. So since your time is in years, you just put it in as 3, okay? So that's what I just wanted to hit home. You know, part A was talking about a time frame of 14 months, so I had to convert it to years by putting it over 12. Part C here, the time frame is in years, so I keep it in years. I don't have to put it over anything. Let's look, and I'll let you finish D. There's not too much. I think you can follow the solutions key for that. Looking at example 3. It says $8,000 is put into an account that earns 3% simple interest for 2 years, 7 months. We want to know what's the accumulated balance in that account after that particular time frame. So figure out, well, how much interest has been earned. So you have put in $8,000, interest rate 3%, 0.03. And then this is the first time that you've seen a combination of units for your time frame. We need it to be in years. So the easiest way to do that is to always go to your smallest unit. So here, since I have years and months, go to the smallest unit. That's the one we want to go with. I want to keep everything in months. So I want to convert those 2 years into months. Well, 2 years then would be 24 months. So 24 months. Add to it the 7 months that you already have. That gives you a total of 31 months. Now take that and convert it to a year, and that would be 31 over 12. Just like I was saying before, don't try to do 31 divided by 12 and get some decimal that you end up rounding. Type this in your calculator from left to right, 8,000 times 0.03 times 31 divided by 12. You're going to get your answer that you want there, which will give us $620. That's how much interest. Always be careful about, making sure you're answering the question. This doesn't want to know how much interest. It wants to know what's the accumulated balance at the end of the time frame. So to find my accumulated balance, A equals principal, how much you put into the account, plus how much, in this case, interest that you earned, $620. So final answer that we're looking here then is $8,620. Okay. I'll let you try example 4 because it runs right in line with what we just did there. All right, we'll flip it on over then. Top of the next page, I want to hit home about, why am I stressing about this not rounding deal? You think about it, if you are ever investing your money or borrowing some money, I want you to see the difference here between taking I'm sure you've in your calculator before have done 1/3 and you've got 0.33333, and here's an example where I've got 1.03333, and then over on the right I just said, well, let's just do 1.03. Let's just round it up because that's the most common thing that I generally see. I want you to see the difference between taking it out a few places versus just taking out, oh, I'll just round it a couple of places. So if you were to evaluate this in your calculator, 5,000 times 1 point, and put all of these digits in here and raising that to the 12th power, should take a second and put that in your calculator so you can see this. You should find that that comes out to a little over $7,000, $7,410.60. Now do the same thing on the right, but this time just put in 1.03. And this time you should get $7,128.80. I guarantee you that if you were looking at a solution key and you saw that big of a discrepancy, you would think you had done something wrong. So and really in a way you have, because what's happening is over here on the right you're rounding too closely, okay, too soon. You should wait and do any kind of rounding, not do any rounding until the very end of your problem, because as you can see here, this is almost a $300 difference. And if, trust me, if that was your money or my money, I'm very concerned about where $300 went, okay. So just be mindful of that, that you don't want to do any rounding until the very end, okay? So there are lots of ways that you can, with these formulas that I'm about to show you, that you can put them in your calculator directly, and it will, in most calculators, if most calculators will accept everything that I show you, as far as if you'll just use the parentheses that I have on your formula sheet, then you'll be good to go. Every once in a while I hit a calculator that won't do it. What I would recommend, if your calculator won't do it, definitely don't round just 2 decimal places. Take it out at least a minimum of 5 to 6 decimal places. That's going to get you much closer to my answer than it is if you do this rounding, okay? All right, so with that said, let's move into the idea of compound interest. Compound interest is where you actually earn interest on your interest, and so it's, you know, it's a very something that we would all like to find. They're hard to find, but they're worth finding. There are 2 types of investments that can involve compound interest: fixed investments versus variable investments. For fixed investments, some examples would be your CDs, savings accounts, money market account. You're guaranteed to make money, and it may not be much money at this, you know, point in time in our economy, but usually interest rates are rather low right now, but nonetheless, you're guaranteed to get a little bit something back. Variable investments is where your gain is not guaranteed. They might go up, they might go down, that sort of thing. Typical ones here that you probably are familiar with: a 401k, stocks, and investing in stocks, mutual funds, things like that. Okay, so what I want to do here at the bottom is talk through what compound interest is doing, and then ultimately give you a formula so we don't have to tackle a table like this each time we work through a problem, and then make sure that you can put this in your calculator and get the final answer. So let's talk through this. So in this example, it says that Sam invests $650 into an account paying 8% interest. It's going to be compounded semi-annually for 3 years. So what we know then is he's putting $650 in, that's my principal, at a rate of 8%, compounded semi-annually. And just an FYI, once you see in a problem that it has the word compounded, then you are no longer even going to think about using the simple interest formula that's on your formula sheet. You're automatically going to go down to the next layer on your formula sheet. Okay, now I'm definitely in compound interest. So I'm compounding it semi-annually for 3 years. So my time's 3 years. Since semi-annually, if you think about it, the store has a semi-annual sale that happens twice a year, so my N is 2. So if you think about it, then in 3 years, if I'm going to get 2 payouts a year, in the total of the 3 years, I'm going to have 6 payouts. And then also to think about this as well, and this is why, I'm talking through a whole lot of stuff here, but this is why hopefully you're going to really appreciate the formula that's down below here, just in the box, that you're going to like, oh, thank goodness we've got this formula. My interest rate, I get 8% for the whole year, so each pay period I'm only going to get 4%. So since I'm going to get 6 payments in those 3 years, 6 payouts, I want to figure out, okay, well, what's my account looking like each time? So at the very first payout, I'm going to earn interest on just what I have in there, that $650 that I've initially put in. I multiply it times my rate, 0.04. I've got one time frame here, so I just didn't put the 1 there. So 650 times 0.04, I'm earning $26 in interest. So now in my account, 650 plus 26, I've got $676 in my account. Here's where compound interest is now in your favor. When it goes to the second time that you get a payout, you're not earning your interest on that 650. Now you're going to earn 650. You're going to earn your interest on the 676. So multiply that times 0.04. Now your interest amount goes up. Add that interest to how much you have. Now you've got a little over $700 in your account, and you just keep on. Okay, now I'm going to earn interest on that $703. Add that back in. Now I'm earning interest on $731. Add that in. Interest on $760. Until ultimately at the end of your very last payout, you're going to have a little over $820 in that account. So luckily, like I said, we've got a nice clear-cut formula to plug this information into so that we don't have to go through an ugly table like this each time. Um, Here, your A stands for your final amount that you'd have in that account. P is how much you put in, your principal, your initial amount. 1 plus your rate should be in as a decimal, so you just take your percent divided by 100. Time is always in years. N is the number of payments that you're going to get in a year, and that corresponds to whether your problem says annually, semi-annually, quarterly, monthly, daily. Those are the common ones that we see, so let's fill that in. If you get an annual payout, then you're only getting one payout a year. Semi-annually, like we talked about a minute ago, twice a year. Quarterly, there would be 4 payouts in a year. Monthly, 12 in a year. Daily, 365 payouts in a year. So these would be your common N values that you would be using for your formula. Where you see parentheses here in my formula, that's where you need to use them whenever you put them into your calculator. So what I'd like to do now is to show you that I can do all of this work up here in the table by using this clear, concise formula. So if I come down to my formula, A equals P, how much I put in, $650, 1 plus my rate, 0.08, divided by 2, because that's my N, divided by my N, and I compound it semi-annually, so twice a year, raising it to the N times T, so my N is 2 times 3 years. So I showed step by step in case some of you have calculators that won't do all of this at one time. Like I said, most will, but every once in a while there will be a calculator that won't. If you will, take a moment and put this in your calculator using every single parenthesis that I use, you should be able to come up with this answer, $822.46, all in one step without having to stop and that sort of thing. Okay. Definitely make sure that you can get this, okay? And the parentheses are vital. All right, so let's flip it over and let's use this formula. We'll do example 6 together, and then I'll let you try 7 on your own. In example 6, it says that Joe started a new job. He received a $5,000 sign-in bonus. He wants to invest this money now so that he can buy a car in 5 years. He invested in a CD, paying 3.35% interest compounded quarterly. We want to know, well, how much money is he going to have in that CD at the end of the 5 years? So he is putting in $5,000. So we know his initial P starting amount, $5,000, at an interest rate of 3.35%. So I'm going to change that to my decimal, 0.0335. N is the number of times it's compounded. It's compounded quarterly. So if you look back on your previous page, it's 4 then. And he's doing this for a period of 5 years. I'd recommend, anytime once you start seeing this compounded idea, that you just go through and you put A, P, R, N, and T, fill in what you know, and then whatever you don't know, that's what you're solving for. So here, I don't know my final amount in my account, I'm solving for A. So I plug in for my P, 5,000, parentheses, 1 plus my rate, 0.0335, divided by my N, which is 4. Raising it to the 4 times 5. And again, like I said, put that in your calculator from left to right using all those parentheses, and you would find that at the end of that 5 years, he would have $5,907.60 in the account. Okay. So that would be how much he would have to put now towards that car in 5 years. Another thing to think about is, well, how much money, if you want to figure out, well, how much money did this CD earn for him? Well, if he initially put in 5,000 and it's grown to a little over 5,900, I can just subtract those two numbers and figure out, oh, his money has earned for him $907.60 over the course of those 5 years, which is not bad. All right, I'm going to let you, like I said, try example 7. I'm going to scoot on down to your next formula. This is the formula that you would use. I call it my planning formula, because this is the formula where you have your end goal in mind. I know that this is a final amount that I want to have. I might want to have money to pay for my kids' education, or retirement, or I want to have a certain amount of money to go on a vacation. It's my plan. I'm trying to plan to have a final amount of money in the future. How much money then? I'm trying to figure out, well, how much money should I put away now so that I have that final amount? Okay, so let's look at, and so it's just a manipulation of our previous formula. That's all that it is. So your A, P, R, N, and T still stand for the same values. So I'm going to come down, let's do example 8 together, and I'll let you try example 9. In example 8, it says, how much money should Harry invest today to have $20,000 in 15 years? We're going to assume that this money earns interest at 7% compounded semi-annually. So it doesn't say what he wants the money for, but we know that he wants this money in 15 years. So the final amount of money that he wants is $20,000. He doesn't have that now. So remember, P is the starting amount. We don't know how much he has. My interest rate is 7%, so 0.07. Compounded semi-annually, so my N is 2, time 15 years. I don't know. That's what we're trying to figure out. How much should he put in now so that he will grow to this 20,000? So that's why I know, going to this formula, 20,000 up top, parentheses on the bottom, 1 plus your rate, 0.07, divided by your N, which is 2, raising it to the 2 times 15. Just like I said before, if you will type this in your calculator in most instances, using all the parentheses that I'm showing here, be sure that you're raising it to the 2 times 15. You're not multiplying it times 2 times 15. It's being raised to the, in this case, the 30th power. Be sure you're raising it to that power. Every once in a while, like I said before, some calculators won't do it. If your calculator won't do all of this in one step, put in the bottom, get that long number, and then do 20,000 divided by that long number. Okay. In our case here, after we've done our division, your final answer then is $7,125.57. Okay, so what that's saying then is if he puts a little over $7,000 away now, in 15 years, invested like we're talking about here in the problem, it's going to grow to the $20,000. Okay, example 9, I'll let you follow that one. And actually the last page, I'm just going to let you work through that page as well. Really what's happening on here on the last page is I've mixed up. When do you use your A formula versus your P formula? Because right now we work them individually and they're not hard. Neither one of them are hard formulas. The hardest part is determining which formula am I supposed to use, and that comes from the context of the problem. So that's why I call that P formula the planning formula. So whenever you start seeing that, they're trying to plan for the future, planning for, like I said, those various things, retirement and education or some trip, or planning to have a down payment on a car, then that's your P formula. But when you actually know how much is being put into an account, then you know your P, you're trying to find, okay, what's the final amount? So that's what I want you to be able to go through and try to figure out by reading through these problems, which formula am I supposed to use? So there's good practice here on this page, and the formula sheet obviously shows you which formula that should have been used. All right, if you have any trouble using these formulas or something like that, don't hesitate, because the formulas only step it up from here. So definitely be sure you contact me and let's get the calculator figured out, because you're going to be calculator dependent in this entire unit. So you gotta get it figured out. All right, thanks.